Okay, so this is question 1. It's the position of the tip of a fan blade in a jet engine, given in millimeters, is given by the formula x equal to 1520 sine 2 theta minus 20 degrees. And the domain is theta is between 0 and 360 degrees. And we're asked to find the values of theta when x is 1100 millimeters. Okay, so the first thing we have to do is let's write the formula, this function, replacing x with the x that we're interested in. So we've got 1520 sine 2 theta minus 20 is equal to this x here, 1100 millimeters. So we notice, first of all, that the period coefficient b is equal to 2. And we can say that there is going to be 2 b solutions. So there's going to be 4 solutions. So we're looking for theta 1, theta 2, theta 3 and theta 4 here. So this is quite a big question, quite a few steps involved, so we'll just do this slowly. So the first thing to do is we need to isolate this sign of the function here. So sign of the argument, sorry, we need to take this 1520 over to the other side and divide 1100 by that. So the first step, we're going to take this 1520 over, so we're going to be left with sine of 2 theta minus 20 degrees is equal to 1100 divided by 1520. Okay, now what we have to do is we take a note that sine, because we're working with sine here, is positive. And this will help us later on when we come to do our cast diagram. Sine is positive because this, on this side of the equal sign, it's positive. It's a positive fraction. If we had negative here, then we'd say sine is negative. But we don't have a negative. We can say that the sine is positive. Now we can go ahead and take the inverse sine of both sides. So this will leave us with 2 theta minus 20 degrees is equal to the inverse sine of this fraction here, 1100 divided by 1520. So if we go to our calculator and we can figure that out. Let's move this calculator a bit closer here. So we're in degrees, so make sure we're in degrees here. We'll go shift sine. I like to use the fraction button, and at the top we've got 1100 divided by 1520. We don't have to do the closed bracket here, but I'll do it anyway. Equals, and it gives us 46.35949944. We'll round this to 2 decimal places, seeing as we're in degrees. So that'll be 46.36. Rounding is crucial for this, so make sure we're rounding this correctly to 2 decimal places. So we'll write that 46.36. So that leaves us with 2 theta minus 20 degrees is equal to 46.36 degrees. Alright, now we can do our cast diagram. Let's move that up there. So I'll just draw a very quick sketch of a cast diagram here. I'll just draw it on this side. This will be a very rough sketch. Oh. Whoops, my apologies. Okay, let's go back down there. Technical difficulties there. There we go. It's hard to draw a straight line. for me. Okay, so what we have is we have our cast diagram. Because up here we said sine was positive, you know that it's going to be in these two quadrants, the A and the S, because all functions are positive in this quadrant and only sine is positive in this quadrant. Because sine is positive, it's going to be in these two. So what we're going to need to find is we're going to need to find the first angle from the 0 degrees, and we're going to have to find the second from the 180 degrees. So let's calculate theta 1. So we have theta 1. I'll put that in a box. So what we've got is we've got 2 theta 1 minus 20 degrees is equal to 46.36 degrees. Because it's in this first quadrant, we just assume that this is what we're looking for. So we can go ahead and take this 20 degrees over to the other side. So 2 theta 1 is equal to 46.36 degrees plus 20 degrees. Because we've taken this 20 minus 20 degrees from this side over to the other side, it becomes positive. And 2 theta 1 is equal to 66.36 degrees. Now we can take this 2 and divide it on the other side, which leaves us with theta 1 is equal to 66.36 degrees over 2, which gives us 33.18 degrees. Okay, I'll do theta 2 on this side. So we got theta 2 I'm looking for. Oh, hey, okay. I'll try and edit that out post-production. Theta 2, there we go. I'll just put that in a blue box as well. Okay, so theta 2 is going to be in the second quadrant here, so we're going to take this angle that we've calculated up here, and we're going to subtract that from 180 degrees. So that's going to be 2 theta 2 minus 20 degrees is equal to 180 degrees minus this 46.36 degrees. And that gives us 2 theta 2 minus 20 degrees is equal to, I'll use a calculator for this, so 180 minus 46.36, 133.64. degrees. Now we'll take the 20 degrees over, so that leaves us with 2 theta 2 is equal to 133.64 degrees plus the 20, and that gives us 153.64 degrees. Alright, I'll just move that up. Finally, we'll take the 2 to the other side, so that's theta 2 is equal to 153.64 degrees all over 2. You might be able to do that in your head, but 153.64 divided by 2 gives us, oops, let's try that again, 76.82. Okay, so we've got theta 1 and we've got theta 2. There are, remember, 4 solutions to this, because we have the period coefficient of 2, so we have 4 solutions. So what we need to do is we need to calculate the period. So we've got the period is equal to 360 degrees divided by the period coefficient b. And that equals 360 degrees divided by 2, which gives us 180 degrees. So to get theta 3, we're going to add 180 degrees to this angle here. So theta 3 is equal to 33.18 plus 180 degrees. That's 33.18 plus 180. And that gives us 213.18. So I'll put that in a green box as well. I'll try and not cover that. Right, I've done it again. Alright, and now we can do number 4, so theta 4. It's going to be 76.82 plus 180. So I'll go our calculator now. That's 256.82 degrees. I'll just underline these here. Alright, so now we've got all of our solutions. So let's just have a recap of this. So the first step was to insert x that we're interested in. So we're trying to solve for theta when the amplitude of this function is equal to this value here. So we've inserted this here. We've taken a note that the period coefficient is 2, so we're going to have 4 solutions. We've isolated the sine value by taking the amplitude to the other side. We've got a fraction. We've noted that this is positive because there's no negative sign here, so sine is positive. We've then taken the inverse sine and solved for that, which gives us our first angle. We then use our cast diagram to find out what quadrants we're looking for our solutions in. We calculate the first angle by taking the phase shift to the other side and then solving by the period coefficient, dividing by the period coefficient to get our first solution. Theta 2 is in quadrant 2, so we know that this is going to be 180 degrees minus this angle that we calculated. We do the same thing. We take the 20 degree phase shift to the other side and add it, which gives us 153. We've divided that by the period coefficient to give us our second angle. We calculate the period, and we add the period to our solutions to get the other two solutions.